So do we choose when it goes live, or is it on live?
It's live, but we choose when we turn the mic on and switch over.
So can we roll here?
No, it's on. Alright, no, it's not.
You're on TV?
Go for it, Looter.
All right, welcome to DevHour. My name is Nathan Burkett. I'm a developer for By the Pixel. And for those who are joining us for the first time here at DevHour, DevHour is a roundtable discussion about a development-driven topic for anyone who's interested, and it's normally given by a developer. In this DevHour talk, we'll be discussing bootstrapping a React app from scratch, and try and keep this talk under an hour so we can allow any questions or anything like that at the end. Live streamers are more than welcome to add any comments or questions in the chat, and we will get to those at the end. All right, so for this talk, kind of a roadmap of what we're going to cover. We're going to start off when you might consider a single-page application. We're going to dive in from there, talk about a Webpack build process for a React app. Then we'll initialize a React app. We'll dive into some React components, and then talk about data store and higher order components. This is a pretty common question that comes up when anybody's deciding to break ground on a front-end application. Do I need a single-page application? And a lot of times they're not always good candidates. There are definitely certain times when they're more useful. Anytime you have to build interaction-rich workflows, CRUD operations, state management around any tasks, those are normally good candidates when you have to respond to a lot of user input or handle and courier actions between the client that a user might be acting on and a server, which is responsible for persisting any data. Single-page applications are generally poor with search engine optimization unless you take into special considerations rendering first page on the server so that the bots that are crawling sites can get all of the content. It's not hidden behind a router or any data that has to be hydrated into the client. And sometimes single-page applications are just a little overly complex for the problem that needs to be solved. So now that we kind of know when we might consider a single-page application, when we're going to start building one, we need to be able to compile it and process it first before we can really start breaking ground on the application and viewing it in our browser and testing it. In this instance, we're going to go through Webpack to build our React application. And for those who don't know, Webpack is a module bundler. It's generally built around JavaScript applications, though it can take a multitude of file types. And the way that Webpack works is it recursively builds a dependency tree that includes every module that your application needs. So people who've seen JavaScript applications where you're requiring certain files at the top, and then you're using them throughout the body of that file, or you're importing modules and you're using them throughout the body of that file. That's how Webpack works through a huge module tree, and it normally works on entry points, and it crawls through your dependency tree, and it packages all those modules into a smaller bundle. And I guess small is a little bit of a relative term because everybody knows that JavaScript bundles can grow out of control as far as size. But the idea is that Webpack can extrapolate certain bundles so you're not including an entire dependency when you only need a small aspect of it.
So does Webpack is that tree shaking then?
Yes, Webpack,
oh, that's cool.
Yeah,
Okay.
Webpack does support tree shaking.
Right.
And the nice thing about Webpack is you can manage all of its dependencies through npm. You can run all the commands that you need to interact with Webpack through npm. So if you have some sort of build server, you can interact with Node and NPM and not have to install Webpack as a global dependency wherever you're using that, whether that's locally or on a server remote.
Do you know if Webpack is agnostic in terms of the package manager? Can you use like Yarn and other?
You can use Yarn.
Okay.
Yep.
Cool.
Generally speaking, and I don't know this for 100% off the top of my head, but generally anything that you can use NPM with, you can use Yarn with.
Yeah.
So let's look at just the basic package.json for Webpack. We'll skip that scripts up there at the top and look at some of the dependencies. This is just the basic dependencies that you would need in order to build a React app. We have Babel at first, which is responsible for transpiling supersets and future-friendly JavaScript back into ES5, which is obviously very widely supported in every common browser. We have this Babel preset React, and that is responsible for transpiling JSX, which is React's XML-like JavaScript syntax back into ES5. Then we have this HTML Webpack plugin, and that's a special plugin that is really only useful in Webpack, and it's responsible for dynamically attaching our hashed bundles in an HTML template. We're going to dive into Webpack and the hashing that it uses that lets us leverage long-term caching, but also cache busting when we do actually affect our bundle. That whole process kind of needs to be dynamic. So Webpack uses this HTML Webpack plugin to kind of streamline that whole process for us when we don't know exactly what the hash of our bundle is going to be. Then we have our React and Redux packages and the Webpack core packages.
So when you talk about cache busting, I'm sure you'll get into this, but if you bust the cache of your application, do they have to re-download the whole application since it's all bundled together?
We're going to get into that a little bit because there's different hashing strategies that you can target with Webpack. You can decide to have a global hash that when you rebuild the entire app, that hash is going to be applied to whatever bundle that you have, or you can have a chunk hash is what it's called, where a hash is specific to a certain bundle. So if you only have certain modules that are responsible or that are present in certain bundles that are changing, only those bundles hashes will change.
Okay.
The other ones will stay the same. So you'll be able to continue to leverage that caching on the bundles that didn't change, but the ones that do have the new modifications will obviously be busted in the browser.
Cool. So this file here, this is what NPM uses or Yarn would use to install your dependencies, right?
Correct.
Okay. All right.
Correct. And we have those scripts there up at the top. For anybody that doesn't know, you can use this block in a package.json to interact with the modules that you have installed locally. The modules being everything that's in your node modules directory.
Okay.
It's nice to have that because then you don't have to have the global dependency of Webpack installed locally on your computer. You can use what's pinned to your certain project. Okay, so now that we went through some of the dependencies, let's look at a basic Webpack config file. And you define the way that the Webpack process runs through a config file. It's just a basic JavaScript object. We have some entry points that we define, and you can see in this entry object the keys to each of those lines. We have app and we have vendor. Those keys will actually represent the output file name of the bundle that we're targeting. So in this instance, we would have an app bundle and we would have a vendor bundle. And underneath it, you see that output object. That's letting Webpack know where we want to output our bundles and the strategy as far as naming that we want to choose. So we have the name, which is going to be inherited from the entry object, those keys that we were just talking about, and then the chunk hash that's going to come after that. And that hash represents what we were just talking about, the cache busting hash that's going to be present on each of the bundles. Okay, continuing down. So this config would almost work out of the box. We would almost not need to change anything in order to start transpiling JSX. The one thing that we have to do is tell Webpack how to handle JSX files. If we were just trying to package up a bunch of JavaScript files, and we changed our entry point, that source/index.jsx, we changed that to just a standard JavaScript file, this Webpack config file would work just as is. So the nice thing about it, you can see here, it's not overly complex. And we know that a lot of build processes, especially for the front end, can grow a little bit out of control. So moving down the Webpack config file, rules are where you tell Webpack how to handle certain files when it encounters them. We have a basic regular expression declaration in that test line right there that is going to tell Webpack, hey, when you encounter a JSX file, or in this instance, we're telling it when you encounter a JavaScript file or a JSX file, do this. And really, we're just passing those files to Babel, which is responsible for transpiling ES6 and React's JSX back into ES5. And the nice thing about Webpack is it doesn't care what files you hand to it. It only cares through the rules that we define how to handle a file type. So we can import Sass styling into our JavaScript files. We can import images and stuff like that. As long as we tell Webpack how we want to handle images or how we want to handle Sass files, it's not going to care what we throw at it.
Okay.
As we move a little farther down the Webpack config file, we're going to get into plugins, which are more dedicated for transforming and custom tailoring some functionality that we might need in the output of the bundles that we create. This Commons Chunk plugin, it will extract modules that are shared between multiple bundles. So if we, say, have a vendor bundle that holds our React libraries, and then we have, say, like a front end and a back end. Say we're building a Node app, and we have a front end bundle and a back end bundle. If we have some utilities that we're sharing between both of those front end and back end bundles, Webpack will be able to track that when it's building our app, and it will extract the common chunks that we're sharing between those into a separate bundle that will be shared between the two. So we're avoiding duplication between our front end and our back end bundle.
Nice.
We talked about the HTML Webpack plugin a little bit, how we use that to let Webpack handle our hashing strategy that we want to use to leverage long-term caching and cache busting. And this right here, we're actually going to demonstrate a little bit what the HTML Webpack plugin does. If we pointed, you can see in this HTML Webpack plugin declaration, we're pointing it towards a certain template. And if that template looked like this, it would output like this with our bundles after it was compiled. So Webpack will handle that for you under the hood by itself.
Thanks.
Now let's talk a little bit about React. I'm sure everybody's heard of React. There are some things about React that I think are very good, and they're things that kind of drove the industry as far as a front-end framework goes. You know, it has many benefits that other frameworks have. It has reusable components with an inheritance model. We can see that with Angular nowadays. It has CLI tools to it, hot module reloading, which comes with Webpack. But one of the great things about React is that it's very performant, and that's largely because of its approach to the virtual DOM and its strict top-down flow as far as application state is concerned. That definitely helps the entire the logic of an application when you don't have a ton of two-way binding between state all over the place. If state can come into an application and just flow downwards, it's going to make everything that much quicker, that much more performant, because there's a lot less handling and a lot less logic that has to happen.
So in React, it's strictly one-way binding?
You can't, and we're going to get into this a little bit, you can't directly mutate, React calls it props, you can't directly mutate it.
Okay.
You have to, and we'll get into this whole strategy, but especially in using Redux, which is what we're going to cover, you want to dispatch actions, and those actions are then picked up by a global function, a global reducer, which reduces those actions into stateful changes for you.
Interesting.
So you never want to be mutating state directly. You're using a reducer to return a future or the next version of state.
Okay.
So you're not interacting directly with it.
Okay. What's a mind shift for me?
Yeah. Yeah, we'll dive into it. I'm getting a little bit ahead of myself, but we'll dive into it.
Real quick, Roland, can you pop that window back open? Was it quiet? There it is. It gets a little warm in here.
So
Beautiful.
when you're starting out with a React app, one of the first things that you need in order to visualize everything that's going to happen in the browser is you need a mounting point for your entire app. And in this instance, you see that we're planning on mounting it into a div with an ID of app. Pretty simple, pretty standard stuff. When we're going to build it on the JavaScript and JSX side, we use this render function that you see here, and we're going to be targeting that div that has the ID app. Our root component will handle the other side of this render call. There's going to be two parameters that need to go into it, but it just needs to be bound to an actual DOM element in order to be able to have the virtual DOM kind of hydrated and visualized inside the actual visible browser DOM that you're going to be able to see and interact with.
I think I'm starting to get the idea.
Let's talk a little bit about components. Components split the UI into independent, reusable pieces and allow us to think about kind of each piece in isolation. And there are two key considerations when dealing with components. They can definitely get a lot more complex, but there's two major considerations that you need to think about when you're approaching your components. And these two have to deal with how data flows and reacts inside of your entire application. So let's take a look at component props or properties. This is what we were talking about a second ago. This is how data flows through your React application. Properties are read-only. They're the preferred way to pass data through the virtual DOM that you have. And like we were talking about just a little bit ago, they're more performant than component state, which we're going to get into, because you can't mutate them directly. There's no two-way binding. There's nothing. It's essentially what comes into the app or what comes into the component is what you're going to get. There's nothing to change. There's nothing to react to when the props come in. They're immutable.
Okay.
You can see here we have this constructor call where we're passing in the props. So the React component, it will actually do that. If you're not going to do anything else in the constructor when you're building up a component, you don't actually have to include this constructor call. It will automatically do this for you under the hood. So you're going to see that in some components coming up where I'm not going to include the constructor just because there's nothing else happening in there.
Right. This default behavior of what it does just
Correct.
hoists it up to the class it's extending.
Correct. So this, you can see here in this comment, this is kind of what we're emulating as far as the props that are going to be coming into this example component. It would be an object that would have a key of data, and it would have a property of title and a property of date. When you're passing anything into a component, or in this instance, when you're passing anything from the constructor into the component, and you're going to have to lift it up to the parent component or the parent class, your first call in a constructor in JavaScript and ES6 always has to be the super call.
Right.
You're gonna throw errors all over the place if that's not the case.
Yeah, so you can't put anything prior to super, which is pretty common in languages. So
Correct.
extensively used like that.
PHP lets you do that.
Yeah, it does. PHP does do a lot though.
They just don't care.
So in this instance, we're taking the props that are passed into this example component, and we are taking the nested data attribute that's inside of the properties, and we're passing that into this child component, which is inside of our current component's body here. We're using the spread operator, which automatically destructures this data JavaScript object for us. Now, that spread operator, that is exactly the same thing as doing this right here. We know that the data object inside of the props has a property of title and date.
Okay.
So destructuring in ES6.
So that's an ES6 thing?
Yes.
Okay. The 3 dots?
Well, this is something that's supported by React. It's not something that is just blindly supported in Babel, which is pretty popular for just being known to transpile ES6 back to ES5. There's a little bit of, correct me if I'm wrong, if anybody else knows this, I think you have to include another package in order to target this behavior specifically. I don't know that Babel supports it out of the box.
I thought it was ES6.
I know that they support destructuring in arrays, but I don't know if they
I thought it was in objects.
with the spread
It's showing
operator.
the specification being 6th edition.
Okay.
Status standard.
Okay. I know you can destructure objects just fine in ES6, but I wasn't sure if you could do it with the spread operator.
Right. I think from what I'm seeing, yes, but
Okay.
So if you had typed this child without the destruct, it would have looked like the next slide, or that's what it renders out to?
Yes. Those two mean the same thing.
Yeah. Okay.
Yeah, you can
so
do
you
it
can use
anyway.
that
but Babel will
syntax.
support it.
Gotcha.
And
I'm
then
always torn between using language like that or being verbose like this, where anybody can look at this and be like, okay, whereas the other is kind of like a bit more hidden.
yeah, it's
It's
a bit more
opinionated.
concise. I mean,
It is.
I definitely think it's nicer and it's a little more elegant and graceful. It looks better to write it like this.
Yeah.
But it depends upon who else is working with it too. If everybody else is
Sure.
aware that this is available and usable, then
Yeah. No, I
I
can
don't
see
see
it.
the harm in it.
No, yeah, for sure.
Okay, so we're passing these properties into this child component that we have defined in this example component. And we would be able to access them and use them like this. So the props that are coming in the constructor, because we took that nested object previously and took it down to just the title and the date, when it's passed in, it's just this shallow object now. And we can access those props directly in the render function and output the component's visual state in the HTML that we're defining here with these properties, just like this. So that kind of gives an introduction into component props, and let's talk a little bit about component state, which should not be considered, or sorry, should not be confused with application state. It's kind of differing concepts because in application state, as we're talking about it, it is completely immutable. What we're calling application state is the props that we just went over. Component state is something different. It's something that you create in the component, and really it should be considered private. It should never be passed around to any other components, any child, anything like that. When we create component state, we really want to keep it localized because it's mutable. There's no guarantees that we have that if we were to pass it to a child that it wouldn't change. We want to keep everything flowing from the top down, so that means we don't want changes coming anywhere bottom up. anything like that.
I have a quick question.
Sure.
Were you going to get into functional React components at all, instead of the class version?
No, I'm just covering class versions in
Okay,
this right
no
here.
problem. Go ahead.
So in this instance, diving into a little bit about component state, this would be an acceptable implementation of it. We only want to update, say, our data store after the user has interacted with some sort of form element or something along those lines. So what we're doing is we're initializing a state object with an input property that we're nulling out. And then if you look down inside of the render function, we have an input element, which we're assigning a ref property. And that ref attribute receives the underlying DOM element as its argument. So we're essentially attaching this DOM element to our state so that when the form is submitted, we could possibly get the value that is in that input and throw it at our data store or something like that. That's kind of how I perceive component state should be utilized in React. Everything here is contained within this component. It's not leaking anywhere else.
Okay.
So if we were to build out something like a to-do list app, the basic components that we might consider is something like a global app, which is going to contain everything, a to-do list component, which will hold all of our to-dos, and then we want to have some sort of component that's going to be responsible for putting new to-dos into our to-do list. Before we really dive into components, we need to think a little bit about our global application state structure and how we want that to work, because it will actually end up driving how our components are structured. So a basic to-do list might be something like this, where we just have an object that has a to-dos collection inside of that, and each to-do is just a basic JavaScript object, which has an ID, some content to it, and a completed flag. So now that we have our initial state, we can go through and start visualizing our entire application with components now. Now this is a view back to our entry point into the React app, which we were attaching to the mounting point that we had in our HTML template. We know that we have this global app component, which we want everything else to fall under. We're not binding anything, any data, or any data store to it yet. We're just kind of mapping out where our components want to be. Inside of that app component, like we talked about, we know that we want to be able to add new to-dos, and we want a to-do list that's going to be responsible for rendering all the to-dos that are in our data store. Let's see. We'll move down into the add to-do component. Looks like this one's a little bit long. In this component, this is essentially what we just looked at a few minutes ago, where we have a component whose has some internal state to it, which is going to be responsible for taking the value of an input and checking to see if that value first is empty, and then if it is not empty, we're going to do some sort of action. We're going to push something at our reducer, which we'll cover in just a little bit, and that reducer is going to be responsible for taking an action and turning it into stateful changes.
I have a quick question.
Sure.
So I noticed you're doing this .state.input equals input. Any reason why you're not using the setState method? Or I don't really know necessarily a difference. I just know setState is typically used, but
Yeah.
it could be a use case.
No, not particularly in this. I'm not actually tracking the value in any way. I'm just asking for it. I'm not mutating it in any way. I'm considering it, if it's empty, I'm going to go ahead and exit early out of this function.
Okay.
But if it's not empty, I'm just going to take it at face value. Now, if I wanted to mutate that at any point, I would probably set state. Yeah.
Okay, that makes sense.
Okay, and moving forward, we're going to take a look at the to-do list, which was also underneath our app component. This component's responsibility is pretty simple. It's just going to be rendering the to-dos collection that we have. When we're rendering a list like we are in this loop, in this loop that you see underneath the unordered list element, you can see we're mapping through the to-dos that are passed in a property in the application state. And when you map through something in React, you want to have some sort of unique identifier on the objects that you are mapping through. This helps React track efficiently when new objects are pushed into your collection or when existing objects change. When you have a unique identifier that React can key on, which you see in that key property right there, it's always going to know this is something that is unique here. Nothing else is going to share this.
There's a functional method for you. Now.
Yep.
So, if something changes the to-do list, does this itself keep track? Like, is this capable of rendering and adding and removing, or where's that logic occurring? Is that in a
So we're gonna dive into that logic.
Okay.
It's being, what we can discern from this right here is anything that's happening. You see these on-click, on-delete handlers that are being set as properties.
Yep.
They're binding to properties that are being passed into this to-do list, which we're kind of foreshadowing right now. They're not actually implemented because they're gonna come into play when we dive into our data store and we're building out actions that interact with our data store and end up changing it. So from this to-do list, we can hop into a basic to-do component. And if we look back, let me see if I can get back to our
Oh, you got yourself in a loop. You're gonna have to refresh that page. Just do a Control R.
Yeah.
Okay.
No, it's still.
Try doing it from your laptop.
Remix.
There we go. Okay. I wanted to look back at the data store. This is defining what properties we know to expect on our to-do. Okay, so if we go back to our to-do, we know that we have a completed property, we have a content property, and we have an ID. So in this render method, we're going to use those properties plus some others that we know were passed in from the to-do list. We have that on-click and that on-delete that we're going to pass to each to-do that they can handle when it comes time.
Can you go back one just real fast? When you reference this inside of these definitions, what is that? What is this?
The component.
Is that the component context?
Yes, that is the
Okay.
component.
Gotcha. So that makes sense.
Okay, let's talk. I'm actually going to fast forward. I've got the states mixed up between. There we go.
Good. Make sure you control from this one. Otherwise, it's gonna keep doing that.
It's still doing that.
It's got a mind of its own.
Push it harder.
There we go.
All right, we're not going to go back to that past slide. We're just going to continue.
This is good.
That last slide was just introducing Redux anyways. And Redux is a predictable state container for React apps. It has, it's kind of opinionated in the way that it wants to manage and affect state, but it's also very simple and very effective in the way that it does it. There's three kind of core common concepts that React adopts to affect data, date store, there's a little typo for
Nice.
to affect your data in the React application. The first one is that it likes to have a single source of truth. You want to be able to rely upon one thing to hold true in your application. You don't want to be looking for validation from multiple areas. You want to have one thing that you can hold. That helps remove the chance of duplication or really anything else being out of sync in your application. The next thing is that state is only, and this is application state, not component state. Application state is read only for the subscribers or the components that are using it. And the next thing is that state changes are made with pure functions. And what are pure functions? A pure function is something that will always return the same output given the same parameters. It doesn't matter where it exists in your application. If you give it the same parameters, it's always going to give you the same output. So a pure function would be something like this. We have a function that multiplies its parameters. If we give it a 2 and a 4, it doesn't matter where it is, it's always going to come back with an 8. That's a pure function. Now, Redux uses reducers, which are pure functions that take the previous state that you had, an action that happens, and it returns the next state. So an example action would be something like this. It doesn't have to be structured like this as far as properties in this JavaScript object, but it's a good idea to have some sort of structure to the way that you want actions to be passed to your reducer. You want to be able to build a dependable and reliable application. So you want to adhere to a certain structure whenever you can. When you're passing an action to a reducer, you want it to be able to depend upon having a type of action, being able to discern what sort of type of action that is, always. So adhering to some sort of structure like this when you're building out your actions definitely helps.
So to be clear, you don't need to have the key type or the key payload, but you've structured it in that way because
Right.
you're looking at time. Okay.
Yeah, and there's Redux Dev Tools it's a Chrome extension,
Chrome.
and it'll show you as the actions fire, hey, here's the type, and it'll just give
Nice.
a list of those types, and so you can
Okay.
see.
So is this
easily
pretty
debug.
standard place structure for an action then?
Yeah.
Okay.
And we have an example action. Let's look at an example reducer. So, like we said before, reducer takes the previous version of the state. It's passed in as a parameter, the first parameter in this reducer function. And it takes an action, and it returns the next version of state. And because they are pure functions, when we're given a state of A and an action of B, we can always depend upon it to return C. It's always going to be dependable in that sort of state. So when we encounter an add to do action in this instance, we want to take the action payload, which we know is a new to do, and we want to just push it on to the end of our current to dos. That spread operator that you see, the ellipsis state dot to dos, that's destructuring the current to dos that we have. So we're just destructuring that array, plopping the new one on behind it, and pushing it back into our to dos there. So let's talk a little bit about Redux and its data flow. We'll start from the React component perspective. The React components can have some sort of action creator. We saw this with the input that we were binding into the component state. We can take an action creator and emit an action that will be picked up by a reducer, or by the reducer or root reducer. You can have multiple reducers in your React application, and you can actually combine them into one root reducer. So you can pull out different, like in our instance, if we wanted to have just a to-do reducer, we could build it that way where we had one reducer that was responsible for all the to-do actions that we had. And then if we ended up building out another aspect of our application, which required a different reducer, we could do that and we could keep them separate. But then when we're bootstrapping our application, we would want to combine them. A reducer then takes that action that we talked about and it computes the next version of the state and it updates the data store, which then sends the state to the new subscribers of the component, or to the subscribers that are listening for that data, that are subscribing to that data in the data store.
Okay. What if there's not anything to store? Can you go directly from the reducer to the
I think it requires the storage.
Yeah,
Well-
then there wouldn't be anything that would go from the reducer to the component, because the component really is just hydrated by the props that are passed into it. So if the reducer isn't affecting the data in the data store, the component's not going to update because it's not going to have any updates that are coming into it.
Right. Okay.
So we were just talking about action creators here that are responsible for emitting an action that gets picked up by a reducer. And this is kind of a lot to look at, but we'll digest it. These are going to be our to-do action creators. We've decided that we want to be able to create a to-do, we want to be able to mark one completed, and we want to be able to delete one. In our instance, all of our actions are fairly simple. They're going to take our action type, which is the strings that we're defining, and they're going to take a to-do object. And the rest is going to be handled by the reducer. These are essentially just dispatches that we're going to use. They're responsible for just firing off the action. They're not responsible for handling anything else. So our to-do, we saw this just a few slides ago. Our to-do reducer would look like this. We saw this create function. We import all of our action types at the top here, just because we're reusing that definition in two places. So it definitely makes sense to give that some sort of dedicated reference, which we were as constants in our to-do actions. So we can use it both in our dispatching functions and we can use it in our reducer here. Let's see. This is our to-do create function. We saw that we're just taking the action payload, we're plopping it onto the end of the current to-dos that are in the state. A mark completed action would be picked up by a reducer like this, where we're, if you look at the state.todos.map, we're essentially mapping through all of the to-dos, and if the ID of the action payload to-do item that is passed in matches the to-do that we're looping through, then we're going to go ahead and flip that completed flag on the to-do. Otherwise, we're not going to do anything to it. So we're looking at the ID to be the unique key to determine whether or not we want to affect the to-do or not.
I think this is what I was thinking of. If you're not affecting it, it's still technically going through the state.
Right. Right.
Yeah, there would be a default case on this that would say just state. Just
Right.
go back to state and how it was.
Nothing
Yeah,
changed
and you'll
yet.
see that right here. The last action that we would want to handle for to-dos would be a delete. And in this case, we're going to filter through all of our to-dos, and if we have an ID that we're picking up from our action payload, we would filter that item out. Otherwise, in our reducer, if what is being passed in doesn't match any of the actions that we're trying to accomplish, we're just going to return the state as it exists at that point in time.
Now, does this end up in the virtual DOM? Is that part of this flow?
Yes.
So if you return just the state and it hits the virtual DOM, it has like some sort of difference checking to where it would or wouldn't update?
Yeah, I guess that's my question. Once this finished reducing and it returns a new state, does that go back to the render call and does it re-render? Or how does that, is that magic that works because of Redux? Or?
So the idea is that we're never directly affecting state. When we want to change state, we're returning a new instance of it.
Which makes sense.
So when we do that, then React knows, hey, we're going to pull all of the data in and we're going to re-render the components that change.
Okay.
So you localize where the changes happen in your state,
Uh-huh.
in certain parts of your state tree. And because of the data that we use to hydrate certain components, only those components will update.
Because they realize the chain that there's a new state.
Right. And there's a new state that happened
Uh-huh.
in their state tree that they're
And then it
subscribing
calls
to.
the render method on
Correct.
itself, and then it updates to them. Okay.
correct.
Yeah, and that's a React magic to answer your questions.
Right.
I'm sure they're doing like some sort of hash matching
Right.
and
Yeah.
figuring that out on the backside.
So we've gone through components, we've kind of figured out our reducers, our state, what it's going to look like, our action creators. We want to talk about higher order components, and this is where we bind our data in our data store to actual components. These don't have any other responsibilities other than being able to pipe data into a component or being able to dispatch actions up to the data store from a component. So they have no UI representation whatsoever. They're just wrappers around React components. So if we were to build a higher order component for our to-do list that was responsible for hydrating the data into it, this is what it would essentially look like. We would import our to-do list component because that's the component we want to affect. The data that we want to end up piping into the component, we're going to use this map state to props function. And we're going to continue walking through this file. It's not finished yet, but this function right here is responsible for mapping a certain part of the data in the data store to the component that we're trying to wrap. So as we move down this file, we want to be able to bring in the action creators responsible for dispatching actions back to our data store, which we are defining as our delete action and our toggle complete action. We want to be able to bind those to our component. So we're going to attach them to some event handlers on to-do click, on to-do delete. And we're going to give them this dispatch wrapper around their function, around their action creator. And we're going to use that in this way. This is the magic that happens with React Redux, this connect function right here. That connect is responsible for mapping the functions that we saw, map state to props and map dispatch to props, and wrapping it around the to-do list. In that instance right there, so this is the entire file right here. We're going to clean it up a little bit, get our imports all in order, and we have the two functions that are responsible for mapping state to props, matching dispatch to props. We're going to apply them to the component that we're targeting. So if we take a look back at our app component, we can see that we no longer need our to-do list. We're going to import our container, our to-do list container instead. And we're going to plug it into our app component. And nothing changes whatsoever with our to-do list component. Everything that's passed in, the data is hydrating the component like we saw before. The to-dos are coming from the props. Those handlers that you see now, this props on to-do click, those are what we defined right here, to be able to dispatch actions back to back to a reducer, which affects our data store.
Nice.
All right, so let's look at our add to do container here. It's a container that we need to wrap our input, which is responsible for creating new to do items. Same sort of idea. It's a little more concise just because we're not mapping any state to the actual input value in this instance. We're just returning a blank object in the map state to props. and we just want to attach one action that it can dispatch and be responsible for, and that's just to create new to-dos. And just like we did with the to-do list container, we'll go ahead and replace our add to-do component in the app component. And that is essentially it for a basic to-do list React app. And we can see right here what we built. We have the initial state that we wanted our application to hold when it was bootstrapped. And these are the to-dos that we have. We have one that is completed. We brushed our teeth today. We still have to fire the missiles, and we still have to surf the web.
It's a weird order of operation.
You know where yeah.
Surf the web first.
No,
it's a normal thing.
You misspelled that with Z?
Was that?
That's cool.
So
Yes, valid point.
we can see by interacting with our components that, we're able to use those on-click handlers to mark something completed. We can interact with our input here and add new to-dos to the list, and we can delete them pretty easily too. So something as simple as that can turn into something like this.
Obviously this doesn't have any persistent state. Where, like in that end of files that we worked on, would you handle like persistence to a database or to some data store? Is that in a container? Like where does that call get made?
It's I guess that's kind of up to personal preference or what people believe. I've seen it handled in the container.
Okay.
You're generally supposed to pass JavaScript objects as actions back to your reducer to handle. There are things that you can do, paradigms that you can follow in Redux where you're actually either calling a function or passing a function which is going to fetch some external data source, and once it gets back, it will actually dispatch that action for you.
Okay.
So it's kind of built into that whole flow as far as the action creator passing it to the reducer.
Gotcha. Okay.
I remember you said something about components should maintain some sort of air gap level between the application state and component states, right? What does two components need to talk to each other?
In that instance, you would have part of your data store that would be responsible for tracking whatever needs to be received between the two. You wouldn't have them talking directly to each
They
other.
would subscribe to the data store?
Correct.
Okay.
I see.
So you change the data, and then when it gets, you had that flow chart at the end, it was the store, and then it sends it to components that subscribe.
Correct.
So they have to listen for the changes, though.
Yep.
Okay.
Yeah, you don't have to do it that way. You can pass the local state down to a child component, but it gets messy, like he was talking
Yeah,
about.
and that's because a child could modify that and then
Mutate it,
Yeah.
and it gets,
Harder to test.
yes. Yeah, that's exactly what that sounds like.
Effects.
Sounds like a nightmare.
And that's one of the great things about, we were talking about reducer, pure functions, because pure functions are, by definition, they're always going to return an expected value given certain parameters. Pure functions are very testable. They're very easily testable because you're essentially saying, given A and B, I'm always going to get C. They're very easy to test.
And then you can do things like you can mock external sources through them, stuff like that.
Yep.
So is testing like a core component of Redux, and I assume, okay, cool.
Yes.
So in your experience, because you use React, right?
Mm-hmm.
Okay. Where would you interact with the database in in a simple app like this?
I can tell you on one of our major projects right now, we have specific calls. So the app we're working on right now, we're creating like a loan application, for example. And so every time someone fills out a field like their first name and then blurs away from that input, we persist that to the database.
Okay,
and so that's just a on blur
Yeah.
call that we have that.
How do you like deal with like errors? Like if it's on blur and that call fails, is it like does that work right into like React and all? Is there like on error handling and stuff like that?
You mean like if if persisting to the database
Yeah.
fails.
Yeah.
Yeah, database is down or something, or
Yeah,
you're
there's a blip
offline
in the
now.
internet, whatever.
Validation fails.
Or non-unique.
Well, the validation fails. It's still there in the front end code.
Right.
That handles that before.
Sure,
it
but that's
persists
easy,
to
right?
the-
It's the asynchronous stuff that gets to be tricky, I imagine.
Yeah. So persisting to the database, I'm not super familiar because I'm not personally the one handling that code. I'm
Right.
strictly a front end dev, and so I kind of sort of have a glazing understanding.
But you get like an on error or something that triggers when it. I assume that comes back. It's got a 500 or something error code associated with it, and React has it built in to handle that. Or
No, you'd have to
Well,
build it, put in cases to handle it.
So it depends. You know, React doesn't come with the resources that you see in Angular. You know, it doesn't come with a router. It doesn't come
Right.
with the ability
yeah,
to
it's just a
fetch.
library.
Yeah. So that implementation would essentially be up to you. Wherever you
Okay.
decide to build it into your application, where you're going to fetch the data source, you have to be able to handle errors there.
Do you just combine it with like another framework that would handle some of those things?
There are plenty of packages, Axios, stuff like that.
Yeah.
I wouldn't even call them frameworks at that point. You're taking components and libraries
Sure,
and
yeah,
stuff,
piece it
plugging them
together,
together.
yeah.
You're essentially building.
Yeah,
your own
like in the
framework.
case of this though, let's say that you click one and it crosses it out, you're making it incomplete, and
Yeah.
obviously in UI you immediately show that, like
Right.
it's
Right.
lined through, but what if there's a persistent state to that happening in the background and that fails, how would you go back and handle that, would that be, that's not the responsibility of React is what you're kind of saying.
Correct.
You would end up calling a render again once that fails, maybe to have it,
You can also push it into local storage and then
right.
Right. So the idea
retry.
in that instance,
Okay.
you
That's
know
good.
that you're having operations that are going to be happening in the background.
Right.
So let's say you have to push something to a database. So it might be a good idea to set something in your data store that says, hey, we're persisting right now. This isn't actually completed right now. It hasn't been finalized.
Sure.
We will wait until we get the 200 back
Okay.
before we actually tell our data store, hey, this is actually complete.
Gotcha.
Yeah.
Well, once again, it's not really reacting. It sounds like React is very purely for the view or rendering the data, and then everything
Yeah.
else you have to find some other components or write it yourself or whatever.
It's very Lego brick kind of thing.
Yeah,
So
which I
that-
like. I much prefer that.
Sure.
Or like something
like,
like
that
something
way
like
you're not
that.
dealing with all the
Amen, brother.
Angular was like, no, you're doing this. Because it's definitely happening. All right.
does make you end up writing a lot of boilerplate code
Yeah.
for each project. So
Yeah.
Right.
it's a trade-off.
Trade off for sure. Cool. Is that's it, right?
That's it.
Did we get any questions?
Perfect
from
timing.
the-
Yeah, this is question and answer time. So.
Yeah, if anybody has anything to
Yeah.
add.
Well,
Same for
did we see
online in
anything-
the
yeah,
chat.
did we see anything in
No,
chat?
nothing in the
Yeah.
chat yet, but we'll see if they come up with anything. So Redux is a package that you bring in.
Mm-hmm.
You tie it into React.
Mhm.
Was Redux built specifically for React, or was that a data store that existed? prior
No,
to
you can use it with Vue. You can use it
Okay.
with Angular.
It's just
It's
data
just a
store you can
paradigm. It's just an approach to managing state.
Okay, that's cool.
The whole idea of having an action which you reduce into stateful changes.
Okay.
I did notice the dependency management kind of occurred within React, but then how do things like other dependency managers like DevHour fall into play?
Power's dying, but
That was a dirty word.
I'm not quite blind, so
they
I'm
like
actually
say
behind a lot
Power
of
on the website. We just have to like update our stuff and run today.
I don't understand your question.
Sorry.
I was just curious if React was taking that role as the sole dependency manager at that point, and you can't use. I can't remember the other one. There's npm and then there's
Well, I don't
Yarn.
think
Yarn.
Yarn, yeah.
React isn't the dependency manager.
No.
Right.
You bring in React through a dependency manager, and
Right.
hopefully you're using Yarn now, or maybe.
Are you talking the
I
import
see.
statements?
Not necessarily. I was thinking about package JSON.
By the way,
stuff.
is
Yeah.
Webpack
That's
taken
in
to
here.
like Gulp and how it builds out assets and CSS and all that? Like, is that what it's doing? It's just a build process? Okay.
Yes, yeah, it is. It definitely offers you a lot more than Gulp can do,
Right.
in my opinion.
I mean, all the things that you
but
described, I know
essentially-
we're doing with one of our Go processes. So I just haven't used Webpack.
If you were to
Yeah.
start a project just to compile CSS, would you say use Webpack, or is that overkill?
Well, is it that we're just going to compile CSS, or are we going to expand it into something else in the future?
Right.
Because then you got to take into account, okay, we need to be able to do that. We want to be able to version, like we were talking about with Webpack. We want to be able to version our bundles effectively and have that cache busting and be able to do that efficiently and not have to think about it. Let something handle it under the hood for us. Or something as simple as transpiling Sass back into CSS. You don't need Webpack.
Right.
It's pretty easy to set up to do it, but you don't necessarily need it for that.
So the paradigm shift is Gulp is very much like a task runner.
Right.
So you're piping tasks
Yep.
one into the other, right?
Yeah.
And you have very declarative control over that. Now the paradigm shift is in Gulp, everything is treated like a module. So your assets, CSS, images, everything is a module. So you get a really, really nice developer conveniences, so that that also like facilitates the CSS and JS stuff.
Okay. And that Webpack handles all of that.
Yeah,
in terms of
yeah.
modules.
Right. Yeah.
Yeah.
Yeah. That's the idea of Webpack's whole approach, is that everything is module. Everything should be extrapolated, and you import it as you need it.
Yeah.
So Webpack takes this approach to modules where it says, I don't care what module you give me, as long as I know how to handle that module. You can throw anything you at me, I just need to know how to handle it.
So if somebody
why
were
you
to
can.
come up with a new front-end language tomorrow, you could plug it into Webpack with just by writing some.
Yeah, you would have to build the underlying handling of it with
Right.
Webpack through some sort of packages or
Plugin,
plugins
right.
or something
Yeah.
like that.
Okay.
But essentially, yeah.
For example, Vue.js uses Webpack.
Right.
Yeah.
Mm-hmm.
And
That's
Webpack,
it.
I assume, existed prior to Vue.js, kind of
Yeah.
thing.
I believe so.
It existed prior to React.
Yeah.
Yeah.
So okay,
Okay.
makes sense.
I have a question. I haven't really used Gulp very much. Does that handle like dynamic changes, like where the user might change something and then maybe
When you say
the
user, you
CS
mean a developer?
Or
no,
the-
I mean like front end users. So
No.
like,
It's
okay.
just
No, it's just like it'll watch like your CSS, and you can make it watch CSS, for example, or Sass and have it compile, or it can
Okay.
minimize your assets or like compress your images. It's all part of the build process, but it has
Gotcha.
nothing to do on the other side. It's just
And
a
you
way
have to write everything yourself.
right.
So
Does
and you can
Webpack
build
do
yeah.
that?
So correct me if I'm wrong, Sam, but like Webpack, it handles those dynamic changes, right? Like if a file is changing on the fly.
yeah, I'm a script kiddie when it comes to Webpack. I haven't even written a plugin. I'm kind of operating within the CLIs of each framework, but it facilitates like, because everything is a module, it understands, what needs what. So that's like, you get really nice things like tree shaking, or you get really nice things like per route bundles and stuff like that. So if you were to do that same thing within Gulp, you need to write that yourself.
Right.
So very much like, you have early in the slide there was catch. There's like is it a regex? It's a
Yeah.
all these
Yeah.
JSX things do run this process for it.
Yeah.
So you would do something very similar in Gulp, but you need to kind of split that bundle and think through that all through yourself. You get a lot less magic under the hood.
Gotcha.
Yeah, all of your CSS or your SCSS in Gulp is contained. You can't really intermix the two. With Webpack, you can throw CSS in your JavaScript or import CSS in your JavaScript files, and it's not going to yell at you. If you try to do that with anything else, it's just going to throw fire.
Right, gotcha. So, question from the chat: what competitors exist that are similar to React for those that don't trust Facebook? And this goes back to the licensing.
Turner.
Vue.
Yeah, of course. But yeah, Vue does exist, but also they just changed the licensing of React to no longer be under Facebook's license. It's
That
under,
happened like yesterday or something.
well, a week ago or something. And it's now is it MIT? Yeah, so it's MIT licensed. So
The cool thing about React is there's enough community behind it. There's huge companies and startups that have built things. There's like what just came out today was the DevTools and Firefox just got written, and so I mean, there are so many people that have so much. I mean, the community is bigger than Facebook. So even though they try to do something super fucking evil,
Really,
like
worst case scenario, it now becomes a fork because it's an open source repository.
Right.
Somebody forks it. The licensing now allows for that without any questions. So.
And if you really hate Facebook, Preact is awesome. It's a 3K, really thin rendering library, and then there's even like other, I can't remember the name of them, but open source projects that you can layer over the top of that to get to like API parity with React.
Right.
Or just use Vue.
Yeah.
Or just use React.
Well, you've used both Vue and React, and so where does your preference fall?
Vue is more different, right? It's not really a replacement to React, I feel.
Right, Vue's more fully featured. You know,
It has a router.
Vue is a framework.
Yeah.
Okay.
So I think I'm able to be more productive with Vue, but that's just because it can do more things, really. I don't know. React kind of grows on you. There's different approaches to both of them. There's definitely some ideas that you can glean from both. The whole idea of state trying to be immutable, passing it down between all your components, that is something that I think once you get into React and you learn it, you probably want to apply it everywhere else that you're going to build something with Vue or with Angular.
And there's a Vuex library that brings that same paradigm in. I personally think like it's really personal preference, but like React is very ES6y, and if you're new to like the single page single page app world, like Vue is going to feel very much like web technologies, and then like you're going to have your mind blown by Angular, for example. It's just a very heavy framework compared to the other two, but
there's definitely a big learning curve, but I think the adoption of TypeScript is in my opinion, is a huge step forward for JavaScript.
Yeah, love TypeScript.
Big time.
And Babel is amazing.
Yeah.
It's good stuff.
Looks like Riot is a React-inspired competitor.
Yeah, there's another, Inferno is another one that's similar to React, but it uses HyperScript. I think it can support JSX pretty easily out of the box, but HyperScript, it looks just like nested arrays and functions instead of using the elegant kind of XML syntax that you see with JSX that looks like HTML. It's just kind of a whole bunch of, in my opinion, a whole bunch of gobbledygook. It's hard to make sense of when you're looking at it. JSX looks like HTML, so it's just...
Yeah.
React is so modular too. It's like JSX is a library in of itself.
Right.
Yep.
It's not a React thing. You can write JSX in Vue if you really wanted to.
Yep.
Yeah, I think that's one of the things where, like Vue.js I use for a lot of my side projects because it's really easy to get something up and running quick. And like Sam, you were talking about prototyping, it's really easy. But the customized, what's the word?
Customizability.
That's the word.
You were almost there.
One beer too many.
Yeah.
But that aspect of React is, I think, what helps it scale a bit better in some cases than Vue, because Vue does constrain you to its patterns.
Yeah.
Angular is much more like that.
Right.
It constrains you much more. Vue is kind of like a minimal version of that, where it doesn't as much.
And I think a funnel. It's like Angular, Vue, React, and
yeah,
that's
React
this
is
is
kind
your
of
trouble
like,
space where you can
React
do whatever
is,
you want.
React can get you in a lot of trouble because you can do almost
So
whatever
much.
you want.
Yeah. Which, you know, is
I prefer just enough to be dangerous kind of thing.
You guys mentioned tree shaking like twice now. What is
tree shaking?
So
thing.
It's a good question.
Yeah, sure. So, you know, I talked in the beginning about we have these large bundles that we might want to extract and use a certain module inside of a huge bundle. It might be one aspect that we're concerned with. We can pull out that module and put it into our bundle, and that's essentially tree shaking. We're shaking that module out of that huge bundle because we don't want the rest of the bloke, we just want that one piece.
Picture a branch with a bunch of leaves on it. You're only wanting one of those leaves. So So you shake it, all the other leaves fall off. You're left with that one thing.
Right, but would
And
that
the
be like
package
a
size is
JavaScript file? Like when you say a bundle, that's
Yep.
like a JavaScript
Could
file.
be
or
could be a
CSS
class. It could be a function.
Okay.
It could be some
And
concept.
Webpack, it's even assets. Like,
yeah.
Okay, gotcha. Cool. I've been wondering that the whole time.
Yeah.
Alright, so
and if you get that to work, let me know.
So here's one from Adam. How do you decide what should be managed by the application state and what should be managed by a Redux store? So that's the difference between the component level and the application level.
So he said application state and Redux store.
Yeah.
Which are those the same thing?
Yeah, those are essentially. Those are the same thing. I guess.
think he means component.
Yeah.
Maybe my
Public
components like-
components.
Yeah.
Yeah.
Any data that you want to end up defining your application that's going to be passed around to different components, you should push up to your data store and let it be shared that way. Passing component state, which by definition it says component state, it doesn't say components state, that should all be localized and that should be private. So
And
you want to
things
keep that
like
self-contained.
component state would be variables or objects or things that the component constructs and sets up. It might be sort of influenced by the props coming in, the application state coming in, but it's strictly for that component.
Right. So we, in React, a lot of times you'll build components around certain interactions. Like we built this add to do component. We built that around the idea of creating an action that's going to persist a new to do into our data store. That component had some internal state that we wanted to use to be able to dispatch this action effectively, but we didn't want anything else to be responsible for any of that internal component state. We wanted to keep that contained.
Okay. So if you ever need it outside the component, now it becomes part of your application state.
Right.
So the to-do list component, its to-dos is application state.
Right.
And the component itself doesn't have a state of to-dos.
Right.
Okay.
And then so the to-do component, in your example, didn't really hold any state either. So there was, or did it?
No, it didn't hold any state, but we were delegating some responsibility of being able to dispatch actions.
Right, okay.
So though, if you add a new to-do or whatever to the list, then does it reconstruct that component to do the to-do list component? Does it call the construct, add, pass and all that, and and then it renders?
Mhm.
So it's all like one-off, like it just redoes it.
But so we attached, when we were talking about those higher order components, we attached a certain part of our data store, and it probably was very misleading because our data store was very shallow. It just had the to-dos array inside of it.
Sure.
Ideally, it would be a lot larger. It would be spanning, a lot more horizontally, vertically. But we were restricting just those to-dos in our data store to that to-do list. So when anything happened inside of the data store in our to-dos collection, it would re-render the to-do list.
Right.
If we had a larger data store and we had stuff happening over here and it wasn't affecting our to-dos, that to-do list wouldn't
Right. It
re-render
wouldn't call the construct and the render.
Right, because our higher order component is binding a certain part of the state to that
Right.
component.
Yeah, that makes sense. Okay.
Yeah, the higher order components is, I'm gonna have to go back and wrap my head around those more, but they make a lot of sense in terms of what they're doing. I like it. I never understood that concept before, so that's good to know.
Yeah, it definitely makes a lot of sense to try and pull out some of that responsibility from things which are just supposed to be displaying.
Makes sense.
Would you consider a lot of the pure functions to be higher order components?
Yeah, that's. What do you mean?
Or
Like
vice
considering. So
I mean, a lot of the higher order components would end up being pure functions, just because of their nature. Of
the
higher
reducers those are definitely the pure functions that end up affecting the application state, but the higher order components.
or at least existing with the components. Yeah.
Yep.
You could we didn't get into this with functional React components. Instead of building it as an ES6 class, you can build a React component simply as a pure function, and so you can do that with higher order components, build them as straight up pure functions. But I think his examples were ES6 classes.
Right.
They were all classes. Yeah.
And then a functional stateless component is what you're referring to. Is
Yeah.
exactly that, where there is no state. The only way to pass a state in is via a prop. So it's a
Yeah.
very, very dumb.
So basically, in this to-do example, the to-do component could be a functional stateless component?
I believe, yeah, it could be.
I'll have to look into that. That's another one I've never heard. And sort of
So,
To the Google machine.
Hmm?
To the Google machine.
yeah.
What's his name? The long curly hair guy, Elliot, on GitHub has a repository that really breaks that down and has a really awesome pattern in terms of a functional component. And I believe he has the philosophy that you should compose your application of those until you need state, and then you refactor as a class. And I believe there's some small performance gains that way, just because you're carrying around less.
Just do.
Yeah,
It's class badge.
told you, curly hair.
Yeah, definitely. Okay.
Did you Google curly hair GitHub?
Not quite. My Google food's strong, not that strong. Alright.
Yeah, this is a great pattern.
Okay, I'll have to
He's the
link
real version of TJ Miller.
this. Yeah. Okay, cool.
But yeah, that's how we build our applications out, is
Cool.
using those functional stateless components until we have to have some sort of local state for whatever reason. Local state being that component state.
And so basically you can use both within a project, but
Mhm.
default to the stateless, and then only introduce the stateful ones when you absolutely need it.
Yeah, not everyone does that like that,
It's-
you know.
It's
But
one opinion. It's one approach.
exactly.
I like that opinion. Sounds like the way to go to me. I've never written a single React application in my life, but
And then the pattern
But
is
you already have
really
opinions.
there you go.
the pattern is really, really clean because you use a fat arrow function, and it's just like
Yeah.
Okay.
it's just less boilerplate.
Yeah.
Which I'm sure when you're standing up an application, there's a ton of boilerplate, as you said already. Might as well minimize it. So.
Well, I mean, you're using something like Webpack to bundle everything. If you can have one certain module who's essentially defining that pure function for you, or doing a lot of the work for you, that just makes for that much less code in your entire application.
Cool. Makes sense to me. All right, we got any more questions from chat? Anybody else here, or I think we're good.
Can you link that that GitHub?
Already
Oh,
did.
nice. Very nice.
Nice.
I don't slouch.
I don't see it in,
Yeah.
in Google YouTube slide.
All right, so for those still on the stream and for those in the room, if you know anybody that would be interested in watching these in the future, have them go to devhour.io, sign up. If you want to give us feedback after we turn the stream off and our feelings don't get hurt online, let us know. If you ever want to present to one of these, pick a topic, let us know. If you want to hear about a topic, let us know. We'll organize it, get you guys on the list. And sort of the goal with this is to disseminate as much useful knowledge as possible in an hour. And at the end of it, have you feel like you got something out of it, and then afterwards you grab drinks. So.
Yeah, and I think it's important that we do this last part and also during talk is to talk, because I've been to plenty of talks and the whole time I'm like, I have questions and I'm like, what does that mean? And like being able to like interrupt is totally fine. I mean, that's the point of this, right? So, and that's the point of the chat room is like, because by the end of the thing, it's like, you've long gone. So like, let's talk about this stuff, let's figure it out and like actually learn something from it, because that's really that's what I think makes this a little bit different than maybe your traditional talk.
Right.
And why we have to kind of keep it smaller, because you can't do that with 30 people in the room where everybody's immediately like intervening or.
Well, and it's like with the spread syntax, so I've got like a list of tabs that are up that we can go over later, but I had completely, from your ES6 conversation, forgotten what the spread, because I'm used to that as variadic, like expression, so I had to sort of reintroduce it into my brain that you'd be structuring this.
Mm-hmm.
So it was nice to be able to get that template in my mind before we moved on. So things like that, I think it's a lot more useful for people like me that are sort of totally lost on the subject because I've been away from front end for so long. But, yeah.
Feel you, buddy. All this front end mumbo jumbo.
Yeah,
like,
you gotta keep crashing and it's hard.
3 dots, split.
Good luck trying to catch up now.
Yeah. All right. So I'm gonna go ahead and end the stream and we'll get out of here.
Goodbye, Will.